All right, welcome back. So this is two sections combined into one, 7.7 factoring special products and 7.8 factoring polynomials completely. So remember back when we learned about multiplying binomials together in class with FOIL, first, outside, inside, last. Now this pattern is back, difference of two squares pattern, and now we're going to use it the other way. Instead of starting with the two binomials and multiplying them together to get a squared minus b squared, we're going to start with a squared minus b squared and have to factor them into a plus b times the quantity a minus b. So you've seen this pattern before, we're just applying it in a different way. All right, let's try an example. So it says factor. So again, factoring means starting with an expression and breaking it down into a product of expressions. So factor the given polynomial using the difference of two squares pattern. The difference of two squares pattern, that's what's on the last slide. That is that a squared minus b squared equals the quantity a minus b times the quantity a plus b. Now here I've got a plus b times a minus b. It does not matter which way you write it because the commutative property of multiplication says you can change the order that you multiply, you will still get the same result. So like 2 times 3 equals 3 times 2. Doesn't matter what order you multiply in. So a minus b times the quantity a plus b is the same thing as a plus b times the quantity a minus b. All right, so here we go. This is a squared minus b squared. It might not look like it right away, but x squared and 16 are both perfect squares. I can rewrite this as x squared minus something else squared. So what squared gives me a 16? And that is a 4 squared is the value 16. So I just rewrote the way 16 looks. 4 squared is still equivalent to 16. So I didn't change the value of the expression. I just changed the way that one of these values looks. All right, so now you can hopefully see that this is a squared minus b squared. In this case, a matches up with x, so a matches up with x, then I have my minus, and then 4 matches up with b. 4 matches up with b. So when you go to factor this, a squared minus b squared, it equals the quantity a minus b times the quantity a plus b. So instead of writing a's and b's, because I don't have a and b, I have an x and a 4, I'm going to write, instead of a minus b, I'm going to put x minus 4. And instead of a plus b, I'm going to put x plus 4. And that is the factored form of this binomial. So I can circle that. So please, 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 on your assignments from now on, please circle your answers. On that last assignment, factoring trinomials, some of you were double checking your answer. So I could double check my answer. Let me just show that step down here. I'll double check my answer by taking my two binomials, x minus 4 times x plus 4, and I can go ahead and FOIL those together. So multiply the first, the outside, the inside, and the last two together, and I would end up with x times x is x squared, x times 4 is positive 4x, negative 4 times x is negative 4x, and negative 4 times 4 is negative 16. These middle two terms, one's positive, one's negative, so those are going to cancel each other out. And I get x squared minus 16. Some of you were on your last assignment circling this last piece right here as your answer, but that's the same thing as circling your initial problem. You got back to what you started with, which means that you factored correctly. But don't circle this last step as your answer because, again, that's the initial problem. So you want to circle the factored form as your answer, but please circle those factored forms on your assignments from now on. All right. I should say if that is your answer. We're going to look at a couple today where we're actually solving equations, but this is just an expression that we're factoring, so our answer is the factored form. So look at example number 2 here. We've got solve the given equation, again, by factoring. So it does say by factoring, so you could actually solve this one algebraically, but the directions say by factoring, so we should follow those directions. So we're going to look at this one and think about that difference of two squares pattern just like on the previous example. Now, this one is not as obvious that it's the difference of two squares, but since it's a difference and we have two terms, you might think, well, it might be the difference of two squares. So we've got to try to make it into that pattern if it is a binomial with subtraction. All right, so can you write this as something squared minus something else squared, a squared minus b squared? So let's take a look. Is something squared 64? And yes, 8 squared is 64, so that is a squared. 8 squared is your a squared. Then you have your minus, and then we need to make this into a quantity squared as well. So 81 is 9 squared. X is already squared, so 81x squared could be written as the quantity 9x. So the 9x quantity squared is 81x squared, because we would have to distribute the squared onto both of our terms, and we get 9 squared x squared. 9 squared is 81. X squared is x squared. So yeah, this is a squared minus b squared. It just doesn't look like it initially. Now this one has an equal 0, so this still equals 0. So this one, like you saw in the last section, we're going to have to factor it so that we can apply the zero product property and get our solutions. But the first step here is noticing that it's a binomial, and in order to factor a binomial that's a difference, we have to think of the difference of two squares pattern. So it has to be able to be written as the difference of two squares pattern, otherwise we would not be able to factor this. All right, so let's move on with it. So since this is in the pattern a squared, so since this is, I'll just put a note here, since this is a squared minus b squared, we can factor that into this guy equals a minus b times the quantity a plus b. So going back to our original binomial here, a is now an 8 and b is now a 9x. So anywhere you see an a down here, we need to put an 8, and anywhere you see a b, we need to put a 9x. So we're going to rewrite this as, instead of a minus b, we have 8 minus 9x is now our b, so 8 minus 9x. And then a again is 8 plus b is now 9x, so 8 plus 9x. And don't forget it equals 0 up here, so it should still equal 0 down here. So that was our first step. Use the difference of two squares pattern to factor. So step 1, I should actually write that out over here. I've got step 1. Use the difference of two squares pattern to factor the binomial. So that's my step 1, and that is what I'm doing here, and then the factored form is right down here. Step 2 is going to be, there we go, step 2 is going to be to apply the zero product property to solve the equation. So the zero product property again says if we have the product of two or more factors, so the product meaning we're multiplying, and we're getting out a 0, then one of those two factors must equal 0. So I'm going to just rewrite that over here, especially for those students that have to still do paper copies for this week. So give me 1 second here to write that over here. So the zero product property says if the product of two or more factors is 0, then at least one of the factors must equal 0. That's what that zero product property tells us. And we've used that in the past. It is back again. And I kept drawing a diagram while we were in class. I kept saying, okay, if we're multiplying things together and getting out a 0, then what must be true of one of these things? And all of you would say one of them must equal 0. So 1 must equal 0. All right, now that that's out of the way, so now we can apply that zero product property. So one of these two factors must equal 0. Either 8 minus 9x must equal a 0, or 8 plus 9x must equal a 0. So one of the two factors must equal 0 in order for the product to equal 0. All right, so we need to solve these equations. So subtract 8 from both sides, we get negative 9x equals negative 8. Divide both sides by negative 9, and we get x equals negative 8 divided by negative 9 is a positive 8/9. So that is one solution. On the other one, if you subtract 8 from both sides, we get 9x equals negative 8. And divide both sides by 9, we get x equals negative 8/9. So on this one, writing your answer in set notation, we get -8/9 or +8/9. So don't think that just because we're going to start getting some of these answers that are one positive, one negative, but otherwise the same value, don't think that all of these problems have those solutions where it's just positive or negative. We are eventually going to start seeing some that they are not the same value. So please don't just get one answer and say, oh, well, it's that or the positive, or this or the negative value. That is not always the case. So that's just for some specific problems. It will not be for all these problems. Please solve both of your equations. Okay, but those are our solutions. That's how we go about solving this equation by factoring. So just to recap, we compared this to the difference of two squares pattern, which allowed us to factor. And then we applied the zero product property, where we set each factor equal to 0 and solve to get our two answers. All right, example 3. So this one, again, says use the difference of two squares pattern, and that, again, is a squared minus b squared equals a minus b times the quantity a plus b. And it says use that pattern to evaluate the given expression. So evaluate means to find the value. So this is an expression. There's only numbers. There are no variables, so we can evaluate this expression. So you could take out a calculator, plug in 19 squared, and then subtract, and then plug in 15 squared. You could get the answer that way. But this one, the directions say use the difference of squares pattern to evaluate. So we should use that pattern. So this is like a little math trick. So this helps you evaluate this in your head, as opposed to needing a calculator, because 19 squared and 15 squared are pretty big numbers, and then to have to subtract those in your head, it's going to take a little while. So the easier, the faster way of doing this is to know this difference of two squares pattern. So a squared minus b squared, this is a squared minus b squared, where a is now 19 and b is now 15. And again, that does factor into a minus b times the quantity a plus b. But now we don't have an a and a b, we have a 19 and a 15. So instead of a and b over here, we need to plug in a 19 and a 15. So instead of writing a minus b, I'm going to write 19 minus 15. 19 minus 15 times the quantity 19 plus 15. So 19 minus 15 is just a 4. And then 19 plus 15 is going to be 34. So this is much easier to evaluate in your head. I mean, 30 times 4 is 120, 4 times 4 is 16, so 120 plus 16 is 136. And that is it. That's the value of 19 squared minus 15 squared. All right, moving on to the next piece here. This is called factoring completely. So this says, this is what we're going to be doing in the rest of this section, and really we have to factor completely anytime we're given a problem to factor. So it says a factorable polynomial, meaning it can be factored, a polynomial that can be factored, a factorable polynomial with integer coefficients. So integers are just whole numbers. So integers would be like -2, -1, so whole numbers including the negatives and 0, 0, 1, 2, so on and so forth. All right, so a factorable polynomial with integer coefficients is factored completely when it's written as a product, so multiplication, a product of unfactorable polynomials with integer coefficients. So we want to take a polynomial and factor it, and our answer in factored form shouldn't have anything else that can be factored. So every polynomial in the factored form should not be able to be factored again. If it can be factored again, then it's not factored completely. So here's an example of factoring a polynomial completely. And we are going to do that in order to solve. So our ultimate goal is to solve the equation. So it does equal 0, so we are able to solve. Again, if you don't have this equal 0, you can't solve just an expression, but since there is an equal 0, we can solve and obtain some values for our answers, the values of x that turn this into a 0, that make this equation true. Okay, so let's start. So the first thing you always want to look for when you are factoring a polynomial is, do you have a greatest common factor? So right away I'm seeing a 2 and an 8. So I'm thinking, yeah, I've got a greatest common factor. Both 8 and 2 are divisible by 2. And then I have an x to the fourth and an x squared, and both of those are divisible by an x squared. So 2x squared is my greatest common factor between those two terms. So what remains if I factor out a 2x squared? In other words, 2x squared times what gives you 2x to the fourth? Well, 2x squared times x squared is 2x to the fourth because we have a 2. X squared times x squared, you'd add the exponents and you get the x to the fourth. Then we have our subtraction symbol here, so we need to have a subtraction symbol here. And 2x squared times what gives you an 8x squared. So 2x squared times 4 is 8x squared. So before this section, you might have looked at this and said, okay, I just set each one of these equal to 0, and I solve and I get my two answers, and I'll be done with it. But now it's a little bit different, because this right here, this x squared minus 4, this is actually the difference of two squares pattern. The difference, let me type this so it goes a little faster. This is the difference of two squares pattern. In other words, it can be factored farther. Make that much smaller, get it out of the way. This is the difference of two squares pattern. In other words, it can be factored farther. All right, so we're not done with this one. We have to factor again. If we don't factor this, if we miss the idea that this is still factorable, we're going to miss one of our answers. So we need to factor x squared minus 4. So I'm just going to make a little note over here. X squared minus 4 is a squared minus b squared. This is x squared minus 2 squared. So this factors into a minus b times a plus b, or x minus 2 times the quantity x plus 2. So that is still factorable. That does factor into two other binomials. So this becomes 2x squared times the factored form of x squared minus 4 is x minus 2 times the quantity x plus 2, and that still equals 0. So don't forget to carry that equals 0 down throughout your problem. All right, so now you look at this and you say, can you factor any one of these polynomials any farther? So here we have a monomial, we can't factor a monomial. Here we have two binomials, but neither of these are the difference of two squares. So no, nothing here is factorable any farther. So this is the factored form of that binomial. And now we can apply the zero product property. So we are multiplying three factors together and getting out a 0. So just like in that last example, two examples ago, we need to apply the zero product property, and that says that one of those factors must equal a 0 if their product is 0. So one of these factors, one of these three factors, must equal 0 if their product is 0. So either 2x squared equals 0, x minus 2 equals 0, or x plus 2 equals 0. So now I don't just have two factors getting set equal to 0, I have three possibilities. All right, so I need to solve all three of these. I'm going to start over on the right side here, subtract 2 from both sides, you get x equals negative 2. On the middle one here, add 2 to both sides, you get x equals positive 2. And then on this one, divide 2 on both sides, you get x squared equals 0 divided by 2 is 0. How do you undo a square? So this is popping up again. So we haven't had a problem with an x squared where we had to solve in quite a while now. So to undo a square, we need to take the square root of both sides. And then we're going to end up with the right-hand side, the square root of 0 is 0. The square root of x squared. So this is something we talked about a while ago now in class. The square root of x squared is the absolute value of x. But on this one, the absolute value of x equaling 0. So this is something that you would have talked about with Mrs. Nelson in the first 3 weeks of school when I was out on paternity leave. So what values of x would give you out a 0? And this one, it's not like the absolute value of x equals 4, where it'd be a positive or a negative 4. This one's the absolute value of x equals 0. And so the only value that you can plug in here that will give you out a 0 is 0. So positive 0, negative 0, if you try to plug those in there, they both give you out a positive 0, but it's 0. There isn't a positive or negative 0. They're both equivalent to 0. So on this one, there's only one solution. X must equal 0 to solve this equation. So we have three solutions. So when we go to write our solution set, we still want to put them in numerical order. So we start with the smallest one and we work our way up to the biggest one, or to the largest number. So my three answers, -2, 0, or 2. Those are the three values that make this equation true. And if you don't believe me, you could always double check by plugging them back in and doing -2 to the fourth, which is going to be a positive 16 times 2 is 32. Plug in the -2 here, you get a 4 times 8 is 32. And if you subtract those, you are going to get a 0. And you can do the same with the 0 or the +2, you're still going to get out a 0. All right, so moving on, we just have two more examples to go. So this one says factor completely. So this one is the first time you have seen a four-termed polynomial that you have to factor. So on this one, we're going to have to introduce a new method of factoring, and that is called, so since there are four terms, since there are four terms in this polynomial, we need to do something called factor by grouping. So how do you factor by grouping? Well, it's called factoring by grouping because we're going to group the first two and the last two terms together. So we're going to look at each one of these sets of terms and we're going to factor out the greatest common factor. So let me just again take a little note here for those people that are still receiving paper copies. So we need to factor out the greatest common factor. I should write that out. Greatest common factor from each group of terms. All right. Factor out the greatest common factor from each group of terms. So what is the greatest common factor? What is the greatest common factor between 2a squared and 8ab? Well, 2 and 8 are both divisible by 2. And then this one has at least one a, and this one has at least one a, so I can also factor out an a. So 2a is the greatest common factor between those terms. So what remains between those first two terms when you factor out a 2a? Again, in other words, if I were to distribute 2a in here, I would have to multiply by something that gives me 2a squared. So 2a times what gives you 2a squared, and that's 2a times a is 2a squared. All right, I have a plus sign here, so carry that down here. And 2a times what gives you 8ab? Well, 2 times 4 is 8. I already have the a here, so that would be 8a if I multiply those together. And I still need a b, so 4b times 2a is 8ab. Do the same thing over here. They both have a negative, and 3a and 12b, well, this one has an a, this one has a b. There's nothing in common with the variables, but 3 and 12 are both divisible by 3, so I can take out a -3. So I'm going to factor out a -3, and then what remains from those two terms when I factor out a -3? Well, in the first one it's a, because -3 times a is -3a, and on the second one it is 4b, because -3 times 4b is -12b. All right, so I factored out the greatest common factor from each one of these groups of terms, and I made a new polynomial, a new expression. So on this one, you might notice there's actually an a plus 4b and an a plus 4b in both of these large terms. So remember, terms are separated by addition or subtraction. So this subtraction sign here is separating this large term and this large term, and they both have an a plus 4b in them. So I'm going to make a little note of that. So notice that both large terms have an a plus 4b in them. This is another greatest common factor. Exclamation point, why not? All right, so let me make this a little bit smaller. I should say that this is another greatest common factor that can be factored out. All right, so we're going to factor out that large, from these large terms, we're going to factor out that expression a plus 4b because they both have an a plus 4b in them. So I can factor out a plus 4b. And if I factor out a plus 4b from this large red underlined term, if I factor this a plus 4b out, What would I have to multiply a plus 4b by to get that large term back? Well, it's only missing a 2a, so I just need to put 2a. So a plus 4b times 2a, well, this is a plus 4b times 2a, or the other way around, 2a times a plus 4b. So this is the first large term. Then I have a minus sign, so carry that down. And then what would I have to multiply a plus 4b by to get this large underlined red term, red underlined term? I'm missing the 3, so minus 3. So a plus 4b times 2a is that first term. A plus 4b times negative 3 is that second large term. So this is the factored form, but is it factored completely? Well, again, we've got two binomials, so the only way we can factor out a binomial or factor a binomial is if there's a greatest common factor, which we know there isn't because we've already taken all those out, or if it's the difference of two squares, which here it is not the difference of two squares. So yeah, this is factored completely. Now, just to be completely correct, in Algebra 2 you are going to learn another couple possibilities for factoring binomials called the sum or difference of cubes, but we're not going to be talking about that in Algebra 1. So in Algebra 1, if it's not the difference of two squares, we can assume that it is not factorable. So that's it. That's factored completely by using something called factoring by grouping. And that's, again, where you group the first two and the last two terms together, you take out the greatest common factor, and then you take out that, again, that greatest common factor. All right, so let's try one last example. It's similar to the last example. It might not look like it right away, but we are going to apply that same method of factoring by grouping, and I'll show you how we're going to do that in just a second. Okay, so in order to solve, this is an equation we do have to solve. In order to solve a polynomial equation, we have to get it set equal to 0 because at some point we'll have to apply that zero product property. So anytime it's not equal to 0, you always want to start by getting it set equal to 0. So let me put another note on here. So we, make it a little bigger. All right, so we want to get the polynomial set equal to 0 so that we can apply the zero product property to solve the equation. All right, so the first thing we're going to do is get this set equal to 0. So how do we do that? Well, we just need to subtract the positive 25x from both sides and subtract 75 from both sides. So when we do that, we're going to end up with x cubed plus 3x squared. That's just from these two terms. Minus, because we have to subtract this from both sides, so minus 25x. And then again, we have to subtract the positive 75 from both sides, so minus 75. And that will now equal 0 because we've subtracted off both of our terms on the right. So we've got it set equal to 0, but we can't apply that zero product property yet because it's not in factored form. So again, we have a 4-term polynomial. So I'm going to make another note on here. 4-term polynomial. Factor a four-termed polynomial by factoring by grouping. Okay, so we need to factor by grouping. Again, factoring by grouping means you take your first two and your last two terms and group them together. And then we need to take out the greatest common factor from each set of terms. So the greatest common factor between these two terms is an x squared. And then what remains, or what would you have to multiply x squared by to get that binomial? So x squared times what gives an x cubed, and that's x squared times x is x cubed. We have a plus sign. X squared times what gives you 3x squared, and that's a 3. X squared times 3 is 3x squared. Between these two terms, we have two subtraction symbols, so I'm going to say we're going to factor out a negative. Both of these terms are divisible by 25, so negative 25 is the greatest common factor. If it was a positive value that you'd be factoring out, so let's say we had a plus signs on here, or maybe this one's a plus sign and that one's a minus sign, you just factor out a positive 25, so you put plus 25. But this is a negative and a negative, so we put a negative 20. So after we factor out that negative 25, then what remains, or what do you have to multiply negative 25 by to get these terms back? So for this term, we need to multiply negative 25 by an x. Negative 25 times x is this term. And to get a negative 75, we need a positive 3, because negative 25 times 3 is negative 75. Again, don't forget your equals 0, so carry that down. And we're almost done, but again, we're looking for the greatest common factor in the large terms. So in this large term and in this large term, separated by this subtraction symbol, are there any other greatest common factors? And yes, there is, again, this x plus 3. So if you go to factor a four-termed polynomial and you don't get the same quantity in parentheses here, then you are not going to be able to factor it. Again, there is another way to get around that you'll learn in Algebra 2, but for Algebra 1, if these are not the same, you can assume that it is not factorable. So now that they both have a greatest common factor of x plus 3, we can take out the x plus 3, and then what would you have to multiply x plus 3 by in this first spot to get this large term? Well, we're missing the x squared, so x plus 3 times x squared, if you distribute the x plus 3, would give you x squared times x plus 3. We have a minus here, so carry that down. And then x plus 3 times what gives you this large term? Well, we're still missing that 25, so put 25 here. Again, it still equals 0, so carry that down. So now on this one, it looks like we factored it. Just comparing it to the last example, we factored this one, we called this our answer, and we were done. But as I mentioned on the last one when we were talking about the answer, this right here is actually the difference of two squares. So on the last one, we didn't run into that where we had the difference of two squares. This one is the difference of two squares pattern. So let me write that down on here, or type that on here real quick. So we do not have this factored completely yet, so we still need to keep moving. All right, so we have to keep factoring until we can't factor any farther. If we don't, again, we're going to miss one of our answers, or potentially miss an answer. So here we've got x plus 3 times x squared minus 25 factors into x minus 5 times the quantity x plus 5, and that still equals 0. So again, this is a squared minus b squared. B squared, this is 5 squared, so I'm using 5 for b. All right, so I now have 3 binomials being multiplied together. None of those are factorable because they're not the difference of two squares, and there's no greatest common factor in any of them. And I'm multiplying them and getting out a 0. So now we can apply that zero product property. That was our original goal, to factor in order to use the zero product property. So one of these three must equal 0 because their product is 0. So x plus 3 must equal 0. X minus 5 must equal 0. Or x plus 5 must equal 0. One of the three must equal 0 in order for the product to be 0. So solve these three equations. We get x equals, by subtracting 3 from both sides, x equals negative 3. By adding 5 to both sides, we get x equals positive 5. Or by subtracting 5 from both sides, we get x equals negative 5. And just to indicate that these are our final solutions, we're going to put them in set notation. So in numerical order, we have negative 5, negative 3, or 5. And those are my three solutions. So that's it. All right, so you can see your assignment off to the right here. I will post the book pages on Google Classroom as well, unless you brought a textbook home with you. So make sure that you're keeping up with this. It says 3 through 13 odds. So for 3 through 13, you have to do the odds, and then you also have to do problem 41. 3 through 9 on page 407, you have to do the odds. But then 12 through 22, you have to only do the evens. And then 23 through 27, you do have to do all of those 23 through 27 problems. All right, so there it is. I'll be watching for your submissions for your assignment. Thanks for watching. Have a good day.